So video has become ubiquitous on the web, and it's become quite easy for everyone to record and edit and distribute high-quality video. But video editing today is also a quite solitary task. It's performed by individuals using single-user applications on personal computers. And only a few video editing tools support collaboration of any kind. Also, there's a gap between the simple tools that casual users use and the sophisticated tools that experts use. We have apps like iMovie on the iPhone for the casual user, and applications like Premiere Pro here for experts. And the simple ones are easy to use but offer limited functionality, and the complex ones are costly and they have a steep learning curve, and there's quite a gap between these two. Also, tools for video editing typically do not support working with both live, recorded, and procedurally generated video. And video editing is trapped in applications. We have applications for casual users, applications for experts, applications for editing recorded video, and applications for editing live video. In our work, we are interested in how we can move beyond this application-centric software paradigm for video editing. And one of the things that we've been exploring is the notion of information substrates. And information substrates are software artifacts that are neither applications nor documents, but can act as either, depending on the use situation. These information substrates, or substrates for short, they are malleable, they can be changed and reprogrammed, and they are composable with other substrates and shareable among users across devices. And these substrates can be manipulated through tools that are embedded in themselves or through other substrates. So what would that mean for video? Well, that would mean that we would have a substrate that could handle recorded and live video, that would allow us to edit and express time-based properties of video and handle multiple video clips. It would embody mechanisms for composing video spatially and composing video with other graphical content, but also allow us to procedurally generate video and manipulate video through programming. With a video substrate, interaction would happen through interchangeable and composable tools rather than applications, and interactions would be collaborative between users, potentially users using different tools and also distributed across multiple devices. But let's try to make that a bit more concrete. So Videostrates is a prototype of a video substrate that we've created to show the potentials of a substrates-based approach to video manipulation. And it's also a toolkit for creating real-time collaborative video editing tools. And a Videostrate is, in essence, a web page that represents a video composition. The URL of this web page can be sent to a service and then be rendered as a video stream. Here we have a simple Videostrate shown to the right, where I've opened up the document to see the HTML, and the same video being rendered in a Videostrate player to the left. And this is just a 15-second video consisting of 3 clips from our accompanying video. Videostrates uses a simple declarative notation where video elements with the composited class will be included in the video based on a given start and end time. Because video now is just a web page also means that we can use CSS to, for instance, create spatial compositions of clips like I've done here, where I've just spatially composed the clips from before. We can also use CSS animations. And notice here that I will now change the document to the right by adding an animation. I just pasted in here, and you'll see that it immediately has effects over to the left. And now we have these wipe down animations when the videos appear. So in Videostrates, any HTML element with the composited class define parts of the video and can have basic attributes specifying when it should start, stop in the overall video, the offset into the source material, and the speed with which the clip should be played. And then we can add CSS styles to spatially composed videos, but also to add animations from a set of predefined animations, such as fade-ins of clips, for example. Videostrates are stored in WebStrates, and WebStrates is a web-based platform where changes to pages on the WebStrates server are made persistent and synchronized to all clients of the same page. And you can see that here, where I have the same WebStrate open in 2 web browsers, and the changes synchronize between them. In the example before, the Videostrate was stored as a WebStrate on a WebStrate server, together with another WebStrate that represents the video player. And the video player asks the Videostrate streamer backend to create a video stream of the given Videostrate and then control the playback. And any change happening to the Videostrate while it's being streamed will live update even while the video is playing. And Videostrates has this simple API for playback of Videostrates, where it's possible to ask the server to stream a specific URL, play, pause, and seek, also record the playback, but also render the Videostrate frame by frame to a video file, and finally also broadcast the stream to an RTMP-based service such as Twitch, for instance. With this very brief introduction to the basics of Videostrates, let me try to show you some of the things that this enables. The first example I'll show you is collaborative video editing. And for this example, we've created this simple timeline-based video editor inspired by Apple iMovie. And this video editor is itself a WebStrate that then transcludes, as it's called, another Videostrate in an iframe. And the Videostrate then consists of references to source material that in the editor is shown in the top left, the timeline shown in the bottom, and then the top right is the preview of the video. So now consider this scenario. We have Alice and Bob here. They're interaction designers that are creating a video mock-up of an interface they're working on. They record some clips on their phones. Then they open a link to the Videostrate on their phone, which allows them to upload the videos. They appear in the video editor, and now they can collaboratively start to cut the video. Bob, he opens up a preview on a large display on another computer that live updates as they cut the video. What Bob he does now is that he opens up a different tool, a subtitle editor, that points to the same Videostrate and starts adding subtitles. The timeline editor doesn't know anything about subtitles, but they still appear in the preview of the video. And finally, they want to add some effects, but the timeline editor is too primitive, so they just open up the developer tools in the browser and edit the Videostrate directly to add an effect like you saw me doing previously. So what did we just see? Well, we saw what you saw here was that a Videostrate enables real-time collaborative editing even between two different independent editors, in this case a timeline editor and a subtitle editor. And we see how Videostrates can enable cross-device interaction, here simply by opening the URL of the Videostrate on a mobile device that then provides a form for uploading video clips. We also see how decoupling video editing primitives from applications allows just using the developer tools of the browser when you hit the ceiling of an application. The editor uses the video streamer API to create a preview, and it also uses a cache on the streamer to generate thumbnails and fast-seek preview videos. The subtitles are simply DOM elements that are added programmatically to the Videostrate and styled using CSS and composited into the video. All right. The second example is programmable video. And here we have Grace. She runs a small one-woman video production and effects company and wants to create a small opening logo for her videos. She records a bit of video on a green screen and then imports that video into a combined Videostrate and computational notebook that she's made that uses a shader to do chroma keying to replace the background with an image. She now renders this to a file that she can export and then import into another Videostrate notebook that she's been working on. And here she overlays the video as a texture in a 3D scene, and while she tinkers with the code, she can see the live updates in the preview to the left. So what you see here was that a complex web page, such as a computational notebook, can be rendered as a Videostrate if it just contains elements that Videostrates understands. And the notebook here in this example is a CodeStrate, which is a notebook system that we've built on top of WebStrates. To programmatically manipulate and generate video, we're using what's called custom elements in Videostrates that allows, for instance, to draw on a canvas when the time of the timeline in the video updates. And the example to the right just shows a simple example of how you can connect a function to when the time updates to draw shapes on the canvas. My third and final example shows how live streaming can be handled with Videostrates. This time the scenario is a comic book convention where Beth, a volunteer, is setting up some cameras for live streaming. And she has an interface implemented as a Videostrate for selecting which feeds to show on the convention webpage. And this also includes ad hoc feeds from mobile phones of other volunteers. And Beth can record these composed streams to a file for archival. And you see that here, where in the bottom right is what Videostrates sees and records, so that's recorded from Videostrates. And then she can also live annotate the video by opening up the Videostrate on her iPad and drawing on top of the video feed. And finally, she hooks this whole thing up to Twitch to save some bandwidth on the convention webpage. So what did you see here? Well, in this example, we are using Videostrates to produce a live stream that can be shared using a platform like Twitch and recorded to a file for archival. We use WebStrate's inbuilt support for creating WebRTC video streams between clients, and then just basic CSS and DOM manipulations to compose the different streams. The Videostrate streamer opens this Videostrate and then simply records what's shown in the browser, which then happens to include some WebRTC-based video streams and some annotations in SVG and a transparent background. Now note that in this Videostrate, it's not time-based. There are no clips with a start and an end. Here we're just using the Videostrates platform to record and stream a composition of live and annotated video streams. So how does Videostrates work? When a client requests the Videostrates server to stream a Videostrate, the vStreamer controller on the Videostrates server instantiates an instance of Firefox in a browser's sandbox. And this sandbox has a frame grabber that grabs all output from Firefox to the GPU. And Firefox now opens a dedicated WebStrate that includes the code for controlling playback. And this WebStrate then transcludes the given Videostrate that we want to render and injects JavaScript and CSS into it for playback. The vStreamer controller now returns a WebRTC stream back to the client. And if we look at the client side, for example, the timeline-based video editor, this is itself implemented as a WebStrate that transcludes the Videostrate being edited and then has a reference to a client-side vStreamer library for controlling playback. And this library handles both playback and also caching of media files for a preview. Notice that the client also transcludes the vCompositor WebStrate, and this is done because all of the playback control happens through a WebSocket-like mechanism in which WebStrates called signaling over this particular WebStrate. Some implementation details I want to mention more can be found in the paper. The Firefox instances, they run in security sandboxes using what's called FireJail, where the frame grabber is injected into as a dynamic library. We use the GStreamer media handling framework for everything related to WebRTC. And we do not actually play videos, but instead we completely control the playback using the seek to next frame method on video elements that in Firefox is extremely performant. And then for CSS animations, they're synchronized to the time by pausing them and them just simply changing their delay. Now, it's hard to say something general about performance as it depends on the complexity of the Videostrate. But on our admittedly powerful consumer-grade computer we use for it, we can have simultaneous playback of 6 Videostrates with 4K source material to a 1280 x 720 output stream. The current implementation of Videostrates has a number of limitations. And first of all, we do not support audio at all. This is future work. And we do not have any error corrections on the WebRTC stream, which means that it's quite sensible to network latency. But Chrome now just supports forward error correction on WebRTC streams, and we did some tests last week that seems quite promising. It's also very easy to do a denial of service attack on Videostrates because you can just render a Videostrate that has an embedded while true loop in it, and then the server dies. We also facing some limitations of the browser. For instance, how it's not possible to render a DOM subtree to a WebGL texture, for instance. So in summary, what Videostrates does is that it moves video editing capabilities from applications down into the medium. And Videostrates is also a toolkit for creating real-time collaborative video editing tools where you can mix using recorded, alive, and procedurally generated video. And we've shown a couple of examples of use, but we believe that Videostrates opens a new design space for web-based collaborative tools working with video that we hope the community will explore with us. And with that, I would like to say thanks for listening.
Any questions? Please, next speaker, please step up.
Zhitong Lu from the University of Toronto. Nice talk. And as I'm more like social computing and about live streaming, I wonder how your tool can actually enable more like, especially in live streaming, actually viewers want to interact more like with other viewers and also with streamers. So do you think your system can enable new ways of interaction between viewers and streamers, for example?
Yes, potentially yes. So for instance, when we stream using Twitch, it's a bit of a one-way street. But in principle, the viewers can also access the web straight that's being streamed, and there could be a particular view on that for the viewers. Of course, there are scalability issues. So when you stream on Twitch, you might have 100,000 users, and the WebStraits platform doesn't support that many concurrent users. But on a smaller scale, that would definitely be possible.
Any other question? Yeah, go ahead.
Hi, Xiong Zhang from University of Rochester. Great talk. So I wonder how hard it is to learn to use this tool. Is it targeting developers, or I wonder how novice users would pick up this tool to create like your cool demos you showed in your talk?
Right. So obviously, doing video compositions by hand requires skills in HTML and CSS. But the idea for us is that we can actually build video editing tools on top of it. And in principle, it's limitless what kind of tools you can build on top. And then you can imagine building tools that are easy or more difficult, or can be extended by the user through installing new components in it or whatnot. But just for a regular web developer, it's very, very easy to express a video composition. And I would say that with someone that has basic HTML skills would find it easier to make a complicated video composition with Videostrates than with a regular video editor. Of course, that's just a claim, but.
Okay, then let's thank speaker, and then let's move on to the next talk.